So suppose this is your strand. Is a helicase, and the direction, suppose the direction is rightward replication fork movement. So at some point, as the replication fork moves, so it will create some pressure, stress, you can say. Here, here, stress, pressure, you can say. So as a result of this pressure, what will happen? Hmm, this portion, if you can follow, this portion will be supercoiled because of the pressure. As the replication fork helicase is moving rightward and the DNA is two strands are pulling apart, so the pressure will create in the this and onwards. So if we think this our strand has like elongated, mm, at some point the strands are elongated, and like if there is no topoisomerase, we are considering that there is no topoisomerase, then at some point this will happen. This is supercoiling. Because of the pressure. So I'm not good at drawing, so I have to bear this. So here, one is positive supercoil here. It is clockwise, right? So if that is clockwise, that is positive supercoiling, and it is anti-clockwise. So it is negative supercoiling. So this is the problem you can see because of the very first unwinding of the helicase and creating pressure here, here, here. So if this supercoil has formed, then the DNA process will not occur. So what the topoisomerase does, you know that your topoisomerase will be here ahead of the replication fork here. So it mainly so this is topoisomerase. It has two domain separate domains, which has very different functions. So this is topoisomerase. Actually, two topoisomerase two. So what does it do actually? You can see this domain. This one domain is this is nuclease. So nuclease domain mainly cut down single strand. So if it cut down, then the pressure will be relieved. So that here, actually it will cut here at some point. Um, so that this actually it will introduce negative supercoiling and positive supercoiling. So it is like here it is rightward clockwise. So it is positive supercoiling here. So the topoisomerase will relieve the pressure and introduce the negative supercoiling so that it can balance. Here, negative supercoiling occurred because this movement, you can see this is here, it is negative anti-clockwise. So the topoisomerase will cut down here and introduce a positive supercoiling. So the other domain, you can see this domain, it is the ligase domain. So once it cuts down and it alleviates the pressure, then it may again it rejoins by this ligase domain. So that's how mainly the topoisomerase works. There's one domain that nuclease. This mainly cuts down single strand. And once the strands are cut down, the pressure is relieved, and then it again it rotates and rejoins the cuts. That is why it is called the temporary cuts. So if you follow this figure, in the absence of topoisomerase, the DNA cannot rapidly rotate, so the stress, torsional stress, builds up. So next, you can see the supercoil. Because of the pressure here, supercoil has formed here and here, supercoiling. So this mainly alleviate by the topoisomerase or DNA gyrase. So it mainly cuts down one nick, one strand, then alleviates the pressure, and so that you can see this reverse strand will move reverse because of this. Here pressure is relieved, so it can move. Um, it it can move reverse direction here. So as a result of reverse direction, actually the supercoiling is neutralized. So that's how mainly the topoisomerase works. Here the and topoisomerase is not shown here, but you can see the topoisomerase is always ahead in front of the replication part.